Hello everyone, welcome to Java Expert. In today's video, we will discuss about circuit breaker design pattern in microservices architecture. What is circuit breaker design pattern? This circuit breaker design pattern used to build the fault tolerant applications. What is fault tolerant? So if you take microservice architecture, each service is going to run independently. It has its own task to perform. So it will run independently always, right? So whenever any one particular service is going down, it's went down, it does not mean that this entire application it is not responding, right? So we have to build application in such a way that even any one microservices went down, the microservices, the entire application should not went down, right? So the circuit breaker design pattern, it is similar to exception, but the circuit breaker design pattern provides us some additional functionalities which we can control the way how we are calling the dependent microservices, basically other microservices, right? Circuit breaker is a design pattern used to detect failures and encapsulates the logic of preventing a failure from constantly recurring unexpected behavior of services. So if we compare with the exception, what we will do what we normally do is when we're calling a microservices, if it got failed, it'll go to the exception case and we'll do what we're supposed to do in the exception block. It will happen for all the calls, every calls. No, right? Even if you're calling 10 times, all the 10 times it got failed, the exception block will be executed, right? But in case of microservice, in case of circuit breaker design pattern, it provides to control the way we are calling it, right? So we know that if continuously service is getting failed, so there is no meaning of keep on calling that particular services. So we have to hold the request further to that and wait for some time to bring back those services, right? So those kind of things can be controlled through the parameters. We have a Resilience4j, which is provided by the Spring Cloud IP things, so that we can use it to implement the circuit breaker design pattern. Right. Now the next point. It's especially useful when all part of our application are highly decoupled from each other. That's the nature of microservice architecture. And failure of one component does not mean the other parts will stop working, as I already explained. Building a fault-tolerant application where failure of some services should not bring entire application down. Right. We already stated that. By implementing circuit breaker design pattern, each component can independently upgraded, maintained without shutting down the entire application. Right? So this is one of the major advantages of implementing with circuit breaker design pattern. So we have 10 or 15 microservices. You can upgrade or you can maintain, you can down any particular microservices for maintenance purpose without bring down the entire application, right? By implementing circuit breaker design pattern, we can avoid unnecessary remote service calls when the particular service is unavailable. That's I already explained, right? So we keep on calling the particular microservices where it is down or it's not responding, then there is no meaning of calling again and again, right? So this is the points now you can note down about the micro circuit breaker design pattern. We'll move to next. There are different states of circuit breaker. When you're going to implement circuit breaker, you have a different state. Like first one is closed. So when everything is normal, so basically when we have a microservice A, we have microservice B, and we're calling A to B, it is everything fine. You're giving the request, you're getting the response. So that state is called closed. Basically, circuit is closed, so the API call is continuous happening, right? Next state is open. The circuit breaker returns on error for calls without executing the function. So basically, when you're calling microservice A to B, microservice B is not responding. Maybe the reason may be various things. It may be down or this, maybe have some error in the service. So in such cases, so we will set some parameters in the circuit breaker system when you're implementing it using Resilience4j. So we'll set some parameter when the circuit should open. So that state called open state. And the one more thing is off open, right? So basically, when the circuit is open, then there is a time we will going to set in the parameter how long it should wait in the open state, and after that it will go for a half open, which means okay, the particular service is not responding. We open the circuit. So when we have to call back again, so we can't keep open for a long time, right? So half open state is a state where we will check the particular service whether it is responding or not after some time, right? So after some time of period, the circuit switches to half open state to test if the underlying problem still exists. Basically, whether the no particular service is still not responding. So for that only. If a single call fail in this half open state, the breaker is once again tripped. If it is success, the circuit breaker reset back to the normal closed state. Basically, in half open state also, we can set the parameter how many requests it should test, right? So we can parameter 3 or 5 or 10 requests. It will know next 10 requests. It will give to the particular service in a half open state if all are success, and it will close the cycle. If we understand these things, we'll move on to next. This is a simple diagram how the circuit breaker design pattern works. Okay, like client and gateway, we know that already things. If you are not aware of what is gateway and all, you can refer our previous video. We implemented API gateway and service one. We have a service two. We have two service. Okay, here the this diagram depicts the open state because the circuit is open. When it is a normal thing, the circuit will be closed. Okay, now I think you would have understand the theoretical part. We are going to implement the same thing in the practical session also. Let's move on to practical. Let's implement the circuit breaker design pattern in practical, right? So we have a many services. We already created it. If you're not aware how to create Spring Boot Node service application, I know you can refer our previous videos so you can able to understand easily. And for this circuit breaker implementation, we're going to use two services. One is fund transfer and rate. Okay, these two services we already created it, right? What exactly is happening is the fund transfer service. We have a process transaction, endpoint, which will call the bank rates service and get the rate, and it will perform the transaction. Now we are going to implement the circuit breaker pattern in the fund transfer. When bank rate service is not available, what's it do? Right. So that's what we're going to implement it now. For that, first, we will add the dependencies. So this is the fund transfer service in format.xml. So we have option. I am using Spring Tool Suite. So if you right click on that, you will find the Spring and add starter. So we can know add the starter of existing XML file itself. So we need a couple of dependencies. One is Resilience4j. So this is the one which actually support us to implement circuit breaker design pattern. And we need a Spring Boot actuator, so which will give the stats, the health related endpoints, so that we can see what is the state of the particular circuit breaker method, right? So I'm adding this. Apart from this, we need a one more. Because that is not coming in this one, so I'll copy it from outside. We need AOP. Basically, this is Resilience4j. It is work based on the aspect oriented programming. So we need this dependency also. I just copied to form.xml, right? So now we have included all the dependencies. Let's move on to the codings. So first, I'll open the fund transfer controller. So this is the fund transfer method, process fund transfer, right? If you open this method, we have a so we're opening this method. What we are doing is here. So from here, we are calling the rate service. This is the rate service endpoint, and we are getting the rate, and we are performing the transaction here. So when the rate service is not available, what we are going to do? So that's what we are going to do. We are going to write circuit breaker for this rate service, right? So going back to controller. So here we have to mention circuit breaker annotation, and we have to mention two parameters. First one is name. So we are providing us rate service, and so here is the place where we have to mention fallback method, right? When the particular rate service is not available, which alternative method should execute, right? In current case, what we are doing is we are calling the rate service and we are getting the rate and we are processing it. In case that particular rate service is not available, we are going to perform the same transaction with some default rate without calling the service, right? So we have to mention the fallback method name here. So method name we can provide as process transaction with default rate. So this is the method we are providing it here. So we have to implement this method here itself, right? So public. So here the rule is the actual method and the fallback method, the signature should be same, right? Basically, the return type also should be fund transfer and this method, and you have to pass this parameter also fund transfer. And here is the thing, one more thing I want to mention. So when the particular service is not available, it is going to throw an exception, right? So for which exception this fallback method should be executed, right? We might have get some different types of exceptions, right? So for which exception this particular fallback method should be executed. So here we are giving us exception. So you can note it, if you can now write a multiple fallback method for each different types of exceptions here, right? So what we are going to do is here, now we are writing one more method, process transaction with some default rate. The method you will write here, all this method. So here we won't call this no service. We'll directly get rate and we are saving that, right? So here we have to write, we have to add it in interface also. Right. So we have implement this method called process transaction with the default rate, and this is the rate will be used here. Right. Now we'll come here. We'll call this. Yes. So that's it. So now and the programmatical way, basically in the programming things we have done that, right? So we have used the circuit breaker, annotation. We gave a name for that, and we wrote the fallback method, and it is we have implemented the same. Now we have to configure few things in the property file. Basically, we have a YAML file here. I'll do the configuration here. And in this YAML file, we have to. So these are the properties we have adding here to demonstrate our circuit breaker how it works. So now we are enabling the management endpoints here, and these all are for our circuit breaker related properties, right? So Resilience4j circuit breaker instances, and this is RAID service, right? So this is the name which we have provided in the circuit breaker notation. So this name should be matched first, right? And this is our the controlling properties of the particular circuit breaker. Okay. So register health indicator. So we have to mention it. We have to make it as true, and failure rate threshold. So when particular services now does not respond, it's getting failure, we have to set threshold. I'm getting one request that's got failed. So that's not mean that the service is still down. That may be many other reasons. So we have to set the threshold. Here we are setting the threshold in percentage, 50 percentage. If 50% of transactions got failed and the particular circuit should open. Okay, so that's we are setting in percentage. Now, minimum number of calls we mentioned is 5. So when I say the 50 percentage out of how many transactions, right? I'm making two transactions, one card failed. That's also 50% only. So we have to give some meaningful number here. Here I'm putting as 5 transactions. I'm giving 5 transactions here, minimum number of calls. Out of 5, if 3 got failed, it is more than 50 percentage. Now the circuit will get open, right? So we have to make minimum 5 transactions. Out of 5, it will check whether the failure is more than 50 percentage. Getting me right? And automatic transition from open to half open enabled. So when circuit is open state, when it should go to half open. It will happen automatically based on the wait duration. Next parameter we have mentioned, no, wait duration in open state. When the circuit is open, it'll wait for 5 seconds and it will go to half open automatically after 5 seconds. So that's the two parameters. And permitted number of calls in half open state. So when circuit is going for half open state, it will try for next three transaction. Next, it will give the next three a request to check whether the particular service is responding or not. So we mentioned as three now. So it will give three requests. And sliding window size is 10. So which means, what is sliding window size? 10 means uh, when you're giving any request, right, the last 10 request outcome will be stored, right? So last 10 request no processed or success or failure, so those stats informations will be captured. So that size only we are defining in this sliding window size. So we're given 10. Sliding window type count based, right? So this entire thing can be configured based on the count based and time based. Also we have one more parameter. So here in 5 transaction, in 5 we are checking the 50 percentage. So instead of that, we have one more parameter called time based. In 1 hour, how many transaction, how much, no, in 1 hour, whether it's a 50% or failed or 20% got failed. So this parameter can be determined based on the time as well as count. We are going to demonstrate using the count based, right? So I hope you understand the circuit breaker related properties. We have many more properties here, so you can check it out here. We have, I think, I've taken for you. Let me show. So here, if you go this, we have many other parameters. So you can just, when you go, when you try for the circuit breaker using Resilience for J, you try with all these parameters. We used a minimal parameter just to demonstrate you, right? Now we'll start the service. So I'm starting fund transfer first. Right. I think fund transfer is started. I'm starting rate service now. So first we'll start both. I'll go for some success case first. Right now, fund transfer and rate service are up and running. I'll go to Postman. I'll give the request. Right. So first we'll check the health because we have enabled health endpoints. So our fund transfer is running in 555 port and actuator and health. Okay, so if you trigger this, we can see our rate service status is closed. The circuit breaker status is closed. We don't make any call, so all the parameters are 0 here, right? Now I'll go to fund transfer endpoint. This is fund transfer endpoint. I'm giving one request now. Yes, we got a response. It is success now. We got a response. I'll go to get no actuator endpoint. We'll see here. Buffered call is, we made one call. Still it is closed and there is no failures, right? Fine. Now we'll bring down the rate service so that we can check how the circuit breaker works. We are bringing down the rate service. Now I'll go to that. Now I'm changing the transaction number alone. Previously we gave 1000 and multiple by rate. I think we are given some 3 point something rate. Some rate we are given based on it came as 10,000 some 300 value. I'm giving one more now. See now. Now this time also give the same amount, but now the amount is coming as 70,000 because we some process for some default rates. We hard code some rate, right? So it is going to the fallback method and it got processed. Now we'll go and check the actuator, check the circuit breaker status. We made 2 calls, one got failed. So what is the threshold we gave? 50 percentage of the for a minimum number of transactions would be 5. We made 2 calls. Now we made another. 3 success, 4, 5. Now we made 5 transactions, right? Out of 5, I think only one is success, remaining 4 are no executed in the fallback method. Now I'll go and check here. See, here we are seeing half open. The reason is waiting state in the open state, we gave us 5 seconds, right? So this 5 seconds is over before we execute in this health endpoint. So it is showing us half open immediately, right? So what we can do is we will change the status, right? So I'm going here, stopping this. We'll extend this time. We gave us 5 seconds, right? We gave us 20 seconds. I'll start it. So we have started it now. We go back again. Now, since we are restarted, everything will be resetted. Now, initial will be closed. Now we will give 1, 2, 3, 4. We set minimum of 5 transactions. We did for 4. If you come and see, still it will be closed only because we set a minimum itself for 5 transactions. Now we'll go for another one. So now we have done 5. All 4. Now 5 failed, which is more than 50%. If you see, it is open state. So wait for 20 seconds. Automatically it will be half open. Right? We'll wait for some time and you can check the same health endpoint. It will be half open. So that's what you have mentioned. It is. It's not a. Yeah, it is 20 seconds is over. Now if you see, automatically circuit is came to half open state from open state. Right now it will what will do is in half open state it will give 3 requests to check whether the particular particular API is bring back. So that's what we mentioned here. So we give 3 more transactions here. Still, note that rate service is down only. Now we give one more transaction. One, we set as 3 in the half open state. We give 2. Come and see, it will be still half open because we set 3 transactions. We give only 2. Now giving one more. Now we gave 3. All 3 got failed. Come and see that it will be open set again. It will go to open again. Right. Now we will start the rate service. We'll check how the circuit is getting closed. Yes, now rate no rate service is up. Now I'll come check the status. It is half open. So here we have to provide another 3 requests. 1, 2. See, we have started, that's why we are coming getting the actual rate from the rate service. And third, yes, all 3 success. Now come and see here. It is now in closed state. Right. So I hope you understand how this circuit breaker design pattern works and the way we are implementing using Resilience4j API. So that's all about this video, guys. I hope you understand, and if you have any feedback, you put your thoughts and comments and like and share this video with your friends and subscribe this channel also. Thank you. We'll see you again in some time. Thanks all.